So this is solving linear systems, and now we're looking at elimination method, having looked at graphical and substitution. This is another way of finding the intersection of lines on a graph, and this is an algebraic method, and it's basically based on adding or subtracting equations and eliminating one of the variables that way, knocking one of them out, hence the name. So sometimes you can just add or subtract them as they are. You'll have like minus x and plus x in one equation, and adding them will just eliminate that way. Sometimes you'll have this kind of a situation. You've got x and 2x, and you've got 2y and 3y. So there's no way of adding or subtracting these equations to knock a variable out. However, if we multiply the first equation by 2, we can change that equation into 2x minus 4y equals 16. Right? Be sure to double everything when you do this. Well, now we compare it to equation b again. 2x minus 3x equals 11. Well, here, you see, I've got 2x and 2x. So now I can apply the elimination technique of doing one equation, subtracting from the other. Now be careful with your negatives here. Get yourself in a bit of a muddle here, but you're doing minus 4y minus a negative 3y. So you've got a minus a negative there, double negative. So that's actually minus 4 plus 3 is minus 1, minus 1y. 16 minus 11 is positive 5, and so what we end up with there is y equals negative 5. My mistake there. And we basically put that into the formula. So negative 5 goes into one of our original equations. So I've gone back to equation A and put in y is minus 5. And I basically get positive 10 there. So I made a mistake there. It should be 8 minus 10 when it goes to the other side. So the solution is actually negative 2. So the value of negative x is actually negative 2, and that is 5. If you were to look at that graphically, then they would intersect at that point as well. Alright, let's look at adjusting both equations. So here I've got 2x and 3x, 2y and 3y. What you really use here is LCMs, least common multiples. So I'm looking at the x's or the y's really. You normally just focus on one. Let's say I'm looking at the x's and I say 3x and 2x would share a common multiple of 6. So I'll just double that and then I'll triple that and I'll get 6x in both equations. And then I can eliminate by subtracting and knocking out the x's. So here I've got my modified equations, 2a and 3b. And what I'm going to do is subtract one from the other. Again, be careful with those double negatives. In this case, it's just minus 4y minus a 9y. Good Lord, I need some more coffee. I've made another mistake. This is minus 4y minus 9y would give you minus 13y equals minus 26. Therefore, 26 is y divided by minus 13. So 26 is positive 2. Now you can just go back and put positive 2 into one of your original equations again. So I've put it back into this equation, and this ends up being 4. So 3x plus 4 is 5. Therefore, you can do up here 3x equals 5 minus 4. And then we would want to solve that, so we'd say if 3x is 1, x is a third. Now if I want to quote that as a solution, then the solution is x is a third, y is positive 2, so there it is, and that's where they graphically would intersect.